Welcome back to the OpenUK Mini Moo lessons. This is lesson 4 and it's called Keep Up Glove. You can start and stop this video at each step if you need more time to keep up with the lesson. Paul saw a great game with a table tennis bat on the Microbit website and wondered if a similar game could be written and used with the Mini Moo glove. The game challenges the player to bounce a ping pong ball repeatedly in the air without dropping it, and it counts the number of times the ball bounces to give a score. But Paul thinks that the gestures used to start and stop the game with the glove could be made a bit more natural to someone wearing a glove. In today's lesson, you will help Paul to design a program for the Keep Up game. By doing this, you will learn about events, Boolean variables, using integer variables for counting, if-else statements. You will also learn what copyright is and why it is important when writing open source. You will need your assembled Mini Moo glove, the Make Code web coding editor, a ping pong ball. You might also find it useful to have access to a large room, as it can be easy for the ping pong ball to go all over the place. Okay, let's get going. As usual, let's make the glove make a small sound when the program starts, so we know the program is working properly. You should be quite an expert at doing this now, but look back at your previous programs if you need a reminder. This is going to be a game with a score, and a variable is a good way of keeping a score. Previously, we used a Boolean variable that had 2 values, true and false. But this time we need more values, so we will use a number variable. Make Code will decide the data type of the variable based on how you first use it. So, as long as you store a number in a variable, you'll be allowed to add 1 to it, and that will make a good score counter. The onShake block will sense movement of your glove and add 1 to the score. There is a small problem here though. When the game is over, if you keep moving your glove, the score will keep counting. You can use the same technique as in a previous lesson and use a Boolean variable to remember if the game is being played or not. So you will have 2 different variables in this program. Score will be a number variable that counts how many times you shake your glove, and play will be a Boolean variable that remembers if the game is playing or if the game is over. You can have any number of variables in a Make Code program as long as they all have different names. So let's make this part work first. Use an onShake block, slot an if block into it. And inside that, slot a change score by 1 from the variables palette. Every time you bounce the ping pong ball into the air, the glove will detect the shake and add 1 to the score. This is a bit like a step counter project, which you might have seen on the Microbit website. Oh, but wait a moment. We can't see the Microbit display. How will we know if this has worked? Let's slot a play note block from the music palette into the if statement, so that the speaker will beep every time it senses movement. Set the duration of the note to 1/8. We don't want the note to play for too long, as otherwise it will slow down the shake sensing, and we might miss a point by accident. Now we need to get the glove to work out if the game has started or not. This part of the program is very similar to the Steady Glove project, so you might want to look back at that to see how that worked. When you place your palm upwards, the screen of the Microbit will be facing downwards, so use an on-screen down block. Slot inside it an if block, and we want this code to run only if the play Boolean variable is false. You can use the not block from the logic palette, and your code will be ready if not play. Alternatively, you could use if play equal to false. It means the same thing, but the first method sounds a bit more like an English sentence, so is sometimes easier to understand. Now slot a set play to true block inside the if block. Do you recognise this pattern of blocks from another project you did recently? Yes, that's right. This is just like the code you used in the Steady Hand game. It's a common code pattern that we can use to only sense the first time something happens. You will see this pattern of code blocks appear in a lot of the projects we make with the glove. There are 2 more things we should do when we detect that the screen is down. Set the score to 0 and play a beep so that you know the game has just started. You can set the score to 0 from the variables palette, and you already know how to play a beep. Use a note length of 1 beat here. This is because we have lots of different beeps already, and the length of the beep will help you to know which beep means what. You could also use a different pitch of note for each beep if you think that will make it easier to play the game. This is getting to be quite a big program already. Let's flash this code to the microbit as it is and see if it works first before finishing the program off. Sometimes it's helpful to build a larger program in small steps and test each step as you go along, and this makes it a bit easier to find and fix the bugs. You should be able to turn the switch on the battery box on, hear the first beep, then turn the glove palm up to start the game, and hear a long beep. Then shake the glove up and down and hear a beep for each shake. Well done! Your game is nearly there, but it's not quite finished yet. When you're playing the game and drop the ping pong ball, we need to find a way to stop the game playing and let the player know what the score is. If you watch someone testing this program, you will notice that when they drop the ball, they will naturally turn their hand over to pick the ball up. So we can use on-screen up as a simple way to detect game over. But hang on a moment, we can't see the microbit display. How will we know what the score is? Let's split the scoring into 3 bands: a low score, a medium score, and a high score. We can then play different sounds depending on what value is in the score variable. Add an on-screen up block from the input palette. Just like before, we only want this gesture to work at certain times. This time we want it to detect the end of the game, so it only needs to work when the game is playing. You can do that by adding an if play then block, and inside that putting a set play to false. So if the game is playing and you reach down for the ball, it will stop the game. Okay, so let's think about these 3 scores. A score less than 5 will be a low score. A score less than 10 will be a medium score. Any more will be a super score. That's 3 different conditions, all based on the score variable. Fortunately, the make code if block can be extended to have lots of conditions in it. It's called an if else block. You won't find one of those in the logic palette, but you can make one by dropping in an if then else block and pressing on the plus symbol at the bottom to add the else if to it. Slot this new big block into the on-screen up so that it is a nested if inside. And then let's put the scoring scheme in. Because this is quite a tricky bit of code to write, let's build it up in 2 steps. The first part needs to read if score less than 5 then. The second part needs to read else if score less than 10 then. Slot all those blocks together first. That's great. We now have 3 different gaps in our if else code for the 3 different scoring bands. So for score less than 5, let's make it sound like a game show sound. Slot in play middle C for 1/4 beat. Then under it a play low F for 1 beat. For a score less than 10, use start melody entertainer repeating once. You can find that in the music palette. For all other scores, the code in the else block will run, so put a start melody prelude repeating once block. Phew, that's quite a big program now, well done. We should remember that a big program is just lots of little programs joined together. Flash your code onto the microbit and play the Keep Up Glove game. Remember, practice makes perfect. Let's just recap the different sounds. When you turn the glove on, a really short pip sound lets you know your code is running. When you turn the glove palm up, you get a long beep sound to let you know the game has started. Every time you bounce the ball in the air, you get a medium length beep to let you know that the glove sensed the ball bouncing. At the end of the game, you either get a high-low tone for a really bad score, or the entertainer theme tune for a medium score. Or, if you get a really good score, you will hear the prelude fanfare. If you find that the glove doesn't always detect a ball bounce, you could write your own more sensitive shake sensing code, similar to what you used in the Steady Glove game. There's an example on the Microbit website under projects called Sensitive Step Counter, if you need a hint on how to do this. What a fab game! Paul will be challenging all his friends to beat his high score now and is very pleased with this game. He's so pleased with it that he's going to share the program listing with his friends as open source so that they can use it and modify it themselves. But hang on a minute, you wrote this program for Paul. Are you happy that he gives this program away, telling everyone that he wrote it? That's not fair, is it? You wrote the program and shared it with Paul. Fortunately, there's a really easy way for you to protect your creation here when you open source your program, called copyright. You can add a small comment into your program that says copyright, followed by your name and date before you share this with Paul. This then makes sure that everyone knows that you are the original creator of the program, which is a fairer way for everyone to use this open source program. If Paul passes on the program to someone else, he has to leave the copyright message in the program, and this is called attribution, because he attributes that you are the original author of the program. See if you can find out how to add a comment pop up in the make code. Let's just finish by seeing how this copyright really works. If you click on the JavaScript button at the top of the Make Code editor, an Explorer box appears below the simulated microbit. Click on the Explorer box, then click on Core and scroll down until you find melodies.ts and click on that. You will see in the coding area the copyright message for the melodies used in MakeCode, attributing them to the MicroPython authors. This is because the melodies you've been using from inside MakeCode were originally written inside MicroPython. They were open sourced, and Microsoft copied them into the MakeCode editor and correctly attributed them to the original authors. Always remember to do this with any programs that you copy or use when you share them with others. Well, that's the end of another lesson. Remember to practice the Keep Up Glove game, and don't forget, always add a copyright message to your programs before you share them with others. See you again at the next lesson. Bye for now.